Today we are going to discuss some of the problems on DIT FFT algorithm. Let us solve the problem. First one, find the 8-point DFT of a sequence x of n is equal to 1, 1, 1, 1, 1, 1, 1, 1, 1 using DIT FFT radix 2 algorithm. We know that for radix 2 DIT FFT algorithm, butterfly diagram will be A, 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 it is B, B, C is equal to A plus B into omega n of R, D is equal to A minus B into omega n of R. So it should be multiplied by -1. We have to write the block arrow marks. This is omega n of R. First, we'll write the fiddle factor values, that is omega 8 of 0 is 1, omega 8 of 1 is 1 by root 2 minus j into 1 by root 2, omega 8 of 2 is minus j, omega 8 of 3 is minus 1 by root 2 minus j 1 divided by root 2, and omega 8 of 4 is minus 1, omega 8 of 5 is minus 1 by root 2 plus j 1 divided by root 2. Then omega 8 of 6 is j, omega 8 of 7 is 1 divided by root 2 plus j into 1 divided by root 2. Let us find the values stage by stage. First, we will find the values for first stage. So, to compute the output of first stage, x1 of 0 is 1 plus 0 into omega 8 of 0, that is 1. x1 of 1 is 1 minus 0 into omega 8 of 0, that is 1. x1 of 2 is 1 plus 0 into omega 8 of 0, that is 1. x1 of 3 is 1 minus 0 into omega 8 of 0, that is 1. x1 of 4 is 1 plus 0 into omega 8 of 0, that is 1. x1 of 5 is 1 minus 0 into omega 8 of 0, that is 1. x1 of 6 is 1 plus 0 into omega 8 of 0, that is equal to 1, and x1 of 7 is equal to 1 minus 0 into omega 8 of 0, which is equal to 1. This is the output for first stage. So these are the inputs for the second stage of butterfly diagrams. Let us compute second stage output. That is x2 of 0. So input is 1 plus omega 8 of 0 into 1, which is equal to 1. Then x2 of 1 equal to 1 plus 1 into omega 8 of 2 is equal to 1 minus j. x2 of 2 is equal to 1 minus omega 8 of 0 into 1, which is equal to 0. x2 of 3 is equal to 1 minus 1 into omega 8 of 2 equal to 1 plus j. x2 of 4 is equal to 1 plus omega 8 of 0 into 1, which is equal to 2. x2 of 5 is equal to 1 plus omega 8 of 2 into 1, which is equal to 1 minus j. x2 of 6 is equal to 1 minus omega 8 of 0 into 1, which is equal to 0. x2 of 7 is equal to 1 minus omega 8 of 2 into 1 is equal to 1 plus j. These are the outputs for second stage. Now, these outputs are inputs for the third stage. Let us compute third stage outputs. Output of third stage, that is x3 of 0 is equal to x of 0, which is equal to 2 plus 2 into omega 8 of 0, which is equal to 4. Then x3 of 1 is equal to x of 1, which is equal to 1 minus j plus 1 minus j into omega 8 of 1 equal to 1 minus 2.414j. x3 of 2, which is equal to x of 2 is equal to 0 plus 0 into omega 8 of 2, which is equal to 0. x3 of 3 is equal to x of 3, which is equal to 1 plus j plus 1 plus j into omega 8 of 3, which is equal to 1 minus 0.414j. x3 of 4 is equal to x of 4, which is equal to 2 minus 2 into omega 8 of 0, which is equal to 0. Then x3 of 5 is equal to x of 5, which is equal to 1 minus j minus 1 minus j into omega 8 of 1 equal to 1 plus 0.414j. Then x3 of 6 is equal to x of 6, which is equal to 0 minus 0 into omega 8 of 2, which is equal to 0. Last one, x3 of 7 is equal to x of 7, which is equal to 1 plus j into 1 minus 1 plus j into omega 8 of 3, which is equal to 1 plus 2.414j. This is the answer for the given problem. Let us write the block diagram for the given problem, butterfly diagram. Already we found the values for all the three stages and we have to write it in the butterfly diagrams. For the first stage, this is for first stage, this is for second stage, this is for third stage. So inputs are x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3, and x of 7. Each should be multiplied with omega 8 of 0 or omega 8 of 2. This should be multiplied by minus 1, minus 1, minus 1. So all the inputs are 1 here. And we got the values for first stage as 1. Outputs are 1. So these are the inputs for the second stage. Should be multiplied by minus 1. Should be multiplied by omega 8 of 0, omega 4 of 0, omega 8 of 2 or omega 4 of 1, omega 8 of 0, omega 8 of 2. These are x1 of 0, x1 of 1, x1 of 2, x1 of 3, x1 of 4, x1 of 5, x1 of 6, x1 of 7. So these are x2 of 0, x2 of 1, x2 of 2, x2 of 3, x2 of 4, x2 of 5, x2 of 6, x2 of 7. So we got second stage outputs as this is 2, so 1 minus j, 0, and 1 plus j. 2, 1 minus j, 0, and 1 plus j. It should be multiplied by, so initially we'll put the arrow marks. We'll put the arrow marks for this. Should be multiplied by minus 1, minus 1, minus 1. This is omega 8 of 0, omega 8 of 1, 8 of 2, and omega 8 of 3. And we have the answers for third stage. X3 of 0, which is equal to 4, which is also equal to x of 0. X3 of 1, which is equal to 1 minus, or x of 1 will write 1 minus 2.414j. Then x3 of 2 is equal to x of 2, which is equal to 0. x3 of 3, which is equal to x of 3, which is equal to 1 minus 0.414j. x3 of 4, which is equal to x of 4, which is equal to 0. x3 of 5, which is equal to x of 5. The answer will be 1 plus 0.414j. x3 of 6 is equal to x of 6, which is equal to 0. And x3 of 7 is equal to x of 7. Answer will be 1 plus 2.414j. This is the final answer for the given problem. Next problem. Find the 8-point DFT of the sequence x of n is equal to 1, 2, 3, 4, 4, 3, 2, 1 using DIT FFT radix 2 algorithm. We know that butterfly diagram for DIT FFT algorithm is A, B, C is equal to A plus B into omega n of R, D is equal to A minus B into omega n of R. Let us solve stage by stage. Before that, we'll write the fiddle factor. Omega 8 of 0 is 1. Omega 8 of 1 is 1 by root 2 minus j into 1 divided by root 2. Omega 8 of 2 is minus j. Omega 8 of 3 is minus 1 by root 2 minus j 1 divided by root 2. Omega 8 of 4 is minus 1. Omega 8 of 5 is minus 1 by root 2 plus j into 1 divided by root 2. Omega 8 of 6 is j. Omega 8 of 7 is 1 by root 2 plus j into 1 divided by root 2. And we know that omega 4 of 0 is omega 8 of 0. Omega 4 of 1 is omega 8 of 2. And omega 2 of 0 is omega 8 of 0. Let us find the output of first stage. Compute the first stage output. X1 of 0 is 1 plus 4 into omega 8 of 0, that is 5. X1 of 1 is 1 minus 4 into omega 8 of 0, that is minus 3. X1 of 2 is 3 plus 2 into omega 8 of 0 is 5. X1 of 3 is 3 minus 2 into omega 8 of 0, which is equal to 1. X1 of 4 is equal to 2 plus 3 into omega 8 of 0, that is 5. X1 of 5 is 2 minus 3 into omega 8 of 0, which is minus 1. X1 of 6 is 4 plus 1 into omega 8 of 0, which is equal to 5. And X1 of 7 is equal to 4 minus 1 into omega 8 of 0, that's equal to 3. These are the output for first stage. Let us find the second stage output. That means first stage output is input for the second stage, that is x2 of 0 is equal to 5 plus 5 into omega 8 of 0, which is equal to 10. X2 of 1 is equal to minus 3 plus 1 into omega 8 of 2, which is equal to minus 3 minus j. X2 of 2 is equal to 5 minus 5 into omega 8 of 0 equal to 0. X2 of 3 is equal to minus 3 minus 1 into omega 8 of 2, which is equal to minus 3 plus j. X2 of 4 is equal to 5 plus 5 into omega 8 of 0, which is equal to 10. X2 of 5 is equal to minus 1 plus 3 into omega 8 of 2, which is equal to minus 1 minus j3. X2 of 6 is equal to 5 minus 5 into omega 8 of 0, which is equal to 0. X2 of 7 is equal to minus 1 minus 3 into omega 8 of 2. which is equal to minus 1 plus J3. These are the inputs for third stage. So final stage output or third stage computations are x3 of 0 which is equal to x of 0 which is equal to 10 plus 10 into omega 8 of 0 which is equal to 20. x3 of 1 is equal to x of 1 which is equal to minus 3 minus j plus minus 1 minus 3j into omega 8 of 1 which is equal to minus 5.828 minus minus 2.414j. x3 of 2 which is equal to x of 2 is equal to 0 plus 0 into omega 8 of 2 which is equal to 0. x3 of 3 is equal to x of 3 which is equal to minus 3 plus j plus minus 1 plus 3j into omega 8 of 3 which is equal to minus 0.171 minus j 0.414. x3 of 4 is equal to x of 4 which is equal to 10 minus 10 into omega 8 of 0 which is equal to 0. x3 of 5 is equal to x of 5 which is equal to minus 3 minus j minus minus 1 minus 3j into omega 8 of 1 which is equal to minus 0.171 plus j 0.414. x3 of 6 is equal to x of 6 which is equal to 0 minus 0 into omega 8 of 2 which is equal to 0, and x3 of 7 is equal to x of 7 which is equal to minus 3 plus j minus minus 1 plus 3j into omega 8 of 3 which is equal to minus 5.828 plus j 2.414. Let us draw the butterfly diagram for all the three stages. So first we'll draw the butterfly diagram. This is for first stage. We have to write the arrow marks multiplied by minus 1. Should be multiplied by omega 2 of 0 or omega 8 of 0. Let us draw the second stage. This is for second stage. Omega 8 of 0, omega 8 of 2. Should be multiplied with omega 8 of 2 multiplied with omega 8 of 0. You have to draw the arrow marks for this. In third stage, so it should be multiplied by, so we'll put the arrow marks first. Omega 8 of 0 should be multiplied by omega 8 of 1, omega 8 of 2, it should be multiplied with omega 8 of 3. Here it should be multiplied by -1. So let us write the inputs. X of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3, x of 7. So the inputs are 1, 4, 3, 2, 2, 3, 4, 1. So we got the answer as x1 of 0, that is 5 we got, x1 of 1, that is 3 we got, x1 of 2, 5, x1 of 3, 1, x1 of 4 is 5, x1 of 5 is -1, x1 of 6 is 5, x1 of 7 is 3. Then these are the inputs for the second stage. We got the output for second stage as x2 of 0 is 10, x2 of 1 is -3 minus j, x2 of 2 is 0, x2 of 3 is -3 plus j, x2 of 4 is 10, x2 of 5 is -1 minus j3, x2 of 6 is 0, x2 of 7 is -1 plus 3j. These are the inputs for third stage. We got final answer as third stage output. X3 of 0 is equal to x of 0, which is equal to 20. X3 of 1 equal to x of 1, which is equal to -5.828 minus j 2.414. X3 of 2, which is equal to x of 2, which is equal to 0. X3 of 3 is equal to x of 3, which is equal to -0.171 minus j 0.414. And x3 of 4 is equal to x of 4, which is equal to 0. X3 of 5, which is equal to x of 5, equal to -0.171 minus j 0.414. X3 of 6 is equal to x of 6, which is equal to 0. X3 of 7 is equal to x of 7, which is equal to -5.828 plus 2.414j. Next problem, compute the 4-point DFT of the sequence x of n is equal to 1, 0, 1, 0 using DIT FFT radix 2 algorithm. We know the butterfly diagram for radix 2 DIT FFT algorithm. A, B, C is equal to A plus B into omega n of R. D is equal to A minus B into omega n of R. This should be multiplied by omega n of R. Next, we'll compute the output for the given problem. So directly we can write this is 4 point. We have only 2 stages. This first stage, this should be multiplied by omega 4 of 0. This will be the second stage. minus 1 omega 4 of 0 should be multiplied by omega 4 of 1. So it is given x of 0 is 1, x of 2 is 1, x of 1 is 0, x of 3 is equal to 0. Then we will find the first stage output x1 of 0 is 2, x1 of 1 is 0. That means we have to add this and we have to multiply by this. A is 1, B is also 1. That should be multiplied by omega n of 0. Omega 4 of 0 is 1. 1 plus 1 into 1, so answer will be 2. And A minus B, 1 should be multiplied, 1 minus 1 should be multiplied by 1. So it is 1 minus 1, hence it is 0. Now x1 of 2 is 0. Similarly, x1 of 3 is 0. This is for the output for first stage. These are the inputs for second stage. We will find out x2 of 0 is equal to x of 0, which is equal to 2. That means here A is 2, B is 0. So 2 plus 0 into something is 0. So answer will be 2. Similarly, here it is x2 of 2, which is equal to x of 2. That means 2 minus 0 into 0. That means it is 2. And here it is 0 we have, here also we have. So x2 of 1 is x of 1, which is equal to 0. x2 of 3, which is equal to x of 3, that is also 0. So this is the final answer for the given problem. Next, we'll solve some of the problems on decimation in frequency FFT algorithms. So first problem, find the 8-point DFT of a real value sequence x of n is equal to 1, 2, 2, 2, 1, 0, 0, 0. It's 8 point using decimation in frequency FFT algorithm. We know the butterfly diagram for DIF FFT algorithms. It should be multiplied by minus 1. This is A and this is B. Here it is C is equal to A plus B. That should be multiplied with omega n of R. A minus B, whole thing should be multiplied with omega n of R. Let us compute the output for first stage. X 1 of 0, C is equal to 1 plus 1, which is equal to 2. X 1 of 4 is equal to 2 plus 0, which is equal to 2. X 1 of 2 is equal to 2 plus 0, which is equal to 2. X 1 of 6 is equal to 2 plus 0, which is equal to 2. Then x 1 of 1 is 1 minus 1 into omega 8 of 0, which is equal to 0. X 1 of 5 is equal to 2 minus 0 into omega 8 of 1, which is equal to 2 into 1 divided by root 2 minus j into 1 divided by root 2, which is equal to root 2 minus j root 2. Then x1 of 6 is equal to 2 minus 0 into omega 8 of 0, omega 8 of 2, which is equal to 2 into minus j, which is equal to minus j2. X1 of 7 is equal to 2 minus 0 into omega 8 of 0, which is equal to 2 into minus 1 divided by root 2 minus j into 1 divided by root 2, which is equal to minus root 2 minus j root 2. Let us compute the second stage output. That means first stage output is input for the second stage. That is x2 of 0 is equal to 2 plus 2, which is equal to 4. x2 of 4 is equal to 2 plus 2, which is also equal to 4. x2 of 2, which is equal to 2 minus 2 into omega 8 of 0, which is equal to 0. x2 of 6 is equal to 2 minus 2 into omega 8 of 0, which is equal to 0. Then x2 of 1 is equal to 0 minus j2, which is equal to minus j2. x2 of 2, x2 of 5 is equal to root 2 into 1 minus j minus root 2 into 1 plus j, which is equal to minus j2 root 2. x2 of 6 is 0 plus j2 into omega 8 of 0, which is equal to j2. x2 of 7 is equal to minus j2 into root 2. Let us compute the third stage output. x3 of 0, which is equal to x of 0, which is equal to 4 plus 4 equal to 8. x3 of 1 is equal to x of 4. x3 of 4 is equal to x of 4, which is equal to 4 minus 4 into omega 8 of 0, which is equal to 0. x3 of 2 is equal to x of 2, which is equal to 0 plus 0, that is equal to 0. x3 of 6 is equal to x of 6 equal to 0 minus 0 into omega 8 of 0, which is equal to 0. x3 of 1 is equal to x of 1 equal to minus j2 into root 2 equal to minus j2 into 1 plus root 2. x3 of 5 is equal to x of 5. We'll get minus j2 into 1 minus root 2. x3 of 6 is equal to x3 of 3 is equal to x of 3, which is equal to j2 into 1 minus root 2. x3 of 7 is equal to x of 7 equal to j2 into 1 plus root 2. We know that the output is in the bit reversed order. So let us find the values in the normal order. Let us write the answers. That means x of 0 is 8, x of 1 is minus j2 into 1 plus root 2, x of 2 is equal to 0, x of 3 is equal to j2 into 1 minus root 2, x of 4 is equal to 0, x of 5 is equal to minus j2 into 1 minus root 2, x of 6 is equal to 0, x of 7 is equal to j2 into 1 plus root 2. Let us write the block diagram for the given problem with all the 3-stage outputs. So here it is vice versa DIT FFT algorithm block butterfly diagram. So it should be multiplied by -1, x of 0 is 1, x of 1 is 2, inputs are given, this is in the normal order, x of 2 is 2, x of 3 is 2, x of 4 is 1, x of 5 is 0, x of 6 is 0, x of 7 is also 0. It should be multiplied by omega 8 of 0, omega 8 of 1, omega 8 of 2, omega 8 of 3. So first stage answer will be x1 of 0 is 2, x1 of 1 is 2, x1 of 4 is 2, x1 of 2 is 2, x1 of 6 is also 2. So let us draw the second stage. -1, -1, so omega 8 of 0, omega 8 of 2, -1, -1, so omega 8 of 0, omega 8 of 2. So second stage output x1 of 1 is equal to 0, x1 of 5 is equal to root 2 into 1 minus j, x1 of 3 is equal to minus j2, x1 of 7 is equal to minus root 2 into 1 plus j. Then the second stage output x2 of 0 is equal to 4, x2 of 4 is equal to 4, x2 of 2 is equal to 0, x2 of 6 is equal to 0, x2 of 1 is equal to minus j2, x2 of 5 is equal to minus j2 root 2, x2 of 3 is equal to j2, x2 of 7 is equal to minus j2 root 2. So third stage should be multiplied by -1, each butterfly should be multiplied with omega 8 of 0. Then x of 0 is 8, x of 4 is 0, x of 2 is 0, x of 6 is also 0. Then x of 1 is minus j2 into 1 plus root 2. X of 5 is minus j2 into 1 minus j root 2. X of 3 j2 into 1 minus root 2. X of 7 j2 into 1 plus root 2. Next problem. Find the 4-point DFT of the sequence x of n is equal to cos of pi by 4 n using DIF FFT algorithm. First we'll write the twiddle factor. Omega 4 of 0 is 1, omega 4 of 1 is equal to minus j. We have to find out x of n. It is given cos pi by 4 of n. Then x of n is equal to 1 comma 1 by root 2 comma 0 comma minus 1 divided by root 2. We know the butterfly diagram for DIF FFT algorithm. It's minus 1 omega n of r. This is a, b, c is equal to a plus b, d is equal to a minus b. It's multiplied with omega n of r. So we can draw the butterfly diagram for 4-point DFT as we have only 2 stages. This is for second stage. Should be multiplied by minus 1. We have to put the arrow marks. So minus 1 so omega 4 of or omega 2 of 0, omega 2 of 0, so omega 4 of 0, omega 4 of 1. So it is given x of 0 is 1, x of 1 is 1 by root 2, x of 2 is 0, x of 3 is minus 1 divided by root 2. For the first stage, we have c is equal to a plus b, a is 1, b is 0, so it is 1, that is x1 of 0, and a minus b, 1 minus 0, that should be multiplied by 1, so here also it is 1. Next is 1 by root 2 minus 1 by root 2 is there. If I add those two, I will get 0, and here I will get minus of minus 1 by root 2, so it is minus j into root 2. These are the inputs for the second stage. It's 1, 0, 1 and minus j root 2. So x of 0 is 1, 1 plus 0 is 1, 1 minus 0 should be multiplied by 1, that means it is also 1. Then x of 1, 1 minus j root 2, x of 3, 3 plus j root 2. We know that for DIF FFT algorithm, input is the normal order and output is in the bit reversed order. So let us write the output in the normal order x of k. That is x of 0 is 1, x of 1 is 1 minus j root 2, x of 2 is 1, x of 3 is 3 plus j root 2. This is the final answer. Next problem, find the 4-point real sequence x of n if its 4-point DFT samples are x of 0 is 6, x of 1 is minus 2 plus j2, x of 2 is minus 2. Use DIF FFT algorithm. So it has given x of n is real sequence. That means it should satisfy the symmetry condition. That is x of k is equal to x star of 4 minus k. Then x of 3 is equal to x star of 1, which is equal to minus 2 minus j2. Then x of k will be x of k is equal to 6 minus 2 plus j2 minus 2 minus 2 minus j2. Let us write the butterfly diagram for DIF FFT algorithm. Should be multiplied by minus 1 and omega n of r. A, B, C is equal to A plus B, D is equal to A minus B should be multiplied with omega n of r. Let us draw the butterfly diagram for 2 stages. This is for first stage. This is for second stage. Should be multiplied by minus 1, omega 4 of 0, omega 4 of 1, omega 2 of 0, omega 2 of 0. So it is given x of 0 is 6, x of 1 is minus 2 plus j2, x of 2 is minus 2, x of 3 is minus 2 minus j2. So first stage output will be 4 minus 4, 8 and 4. These are the inputs for second stage. So it is given x of 0. So we have to find out x of n. So we have to multiply it by 1 by 4 for each stage. Then x of 0 is equal to 0. X of 2 is equal to 2. X of 1 is equal to 1. X of 3 is equal to 3. Then x of k is x of k or x of n is equal to 0, 1, 2, 3. This will be the answer. Let us solve some of the problems on inverse radix to DIF FFT algorithm and DIT FFT algorithm. It is given x of k is equal to 0, 0, 0, 0, 8, 0, 0, 0. Find x of n using radix to IDIF FFT algorithm. So here we have to use DIT formula, IDIF, we have to use DIT formula. So butterfly diagram will be A, B, omega n of star r we have to multiply. This is -1, C is equal to A plus B into omega n of star r, and D is equal to A minus B into omega n of star r. So let us directly draw the butterfly diagram. So each stage we have to calculate the values. So for this, input is in the bit reversed order: x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3, and x of 7. So inputs are 0, 8, 0, 0, 0, 0, 0, 0. So first stage output will be according to the formulas is 8 minus 8, 0, 0, 0, 0, 0, 0. Next draw the second stage butterfly. Should be multiplied by -1 and omega 8 of star 0, omega 8 of star 2, omega 8 of star 0, omega 8 of star 2. Should be multiplied by -1. Let us put the arrow marks. So these are the inputs: 8 minus 8, 0, 0, 0, 0, 0, 0. So second stage output will be 8 minus 8, 8 and minus 8. So here it is 8 plus 0 multiplied by 1, 8, 8 minus 0, once again is 8. Once again minus 8 plus 0 and minus 8, minus 0 is multiplied by 1, hence it is minus 8 itself. Last stage is should be multiplied by -1 and omega 8 of star 0, star 1, omega 8 of star 2, omega 8 of star P. Let us put the arrow marks. Eight, -8, 8 and -8 are the inputs. These four stages are zeros. Zero, 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 zero. So output will be, it is 8, -8, 8, -8, 8, -8, 8, -8. So it is inverse. So at the each stage we have to multiply it by 1 by 8. So answer will be, it is x of 0, which is 1, x of 1 is also -1, x of 2 is equal to 1, x of 3 is also -1, x of 4 is 1, x of 5 is -1, x of 6 is 1, x of 7 is also -1. So we can write x of n as, x of n is equal to 1, -1, 1, -1, 1, -1 and 1, -1. This is the final answer. Next problem, given x of k is equal to 36, -4 plus 9.656j, -4 plus 4j, -4 plus 1.656j, -4 minus j 1.656, -4 minus 4j, -4 minus j 9.656. Find x of n using radix to IDIF, that means inverse DIF FFT algorithm. That means we have to use DIT formula and we have to multiply the conjugate of fiddle factor, and at the end we have to multiply it by 1 by n. Let us draw the butterfly diagram for this. We have 3 stages. So first stage, we have to put the arrow marks. Star 0 we have to multiply. So x of 0 is 36, x of 4 is -4, x of 2 is -4 plus 4j, x of 6 is -4 minus 4j, x of 1 is -4 minus 9.656j, x of 5 is -4 minus j 1.656, x of 3 is -4 plus 1.656j, x of 7 is -4 minus j 9.656. So first stage answer will be 36 minus 4, it is 32, and 36 minus of minus 4 multiplied by 1, it is 40. Minus 8, 8j, minus 8 plus 8j, 11.312j, minus 8 minus 8j, 11.312j. So second stage will be should be multiplied with omega 8 of star 0, omega 8 of star 2. Omega 8 of star 0, omega 8 of star 2. These are the inputs for second stage. We get the output as for second stage 24, 32, 40, 48, minus 16, 4.312j, minus 11.312, 16j, 11.312j, plus 11.312. The final stage will be should be multiplied by minus 1, omega 8 of star 0, omega 8 of star 1, omega 8 of star 2, omega 8 of star 3. These are the inputs for third stage. That time we have to multiply it by 1 by 8. So x of 0 will be 1, x of 1 will be 2, x of 2 will be 3, x of 3 will be 4, x of 4 will be 5, x of 5 will be 6, x of 6 will be 7, x of 7 will be 8. This is the answer for the given problem. Let us solve the problems on IDFT of x of k using radix 2 IDIT FFT algorithm. Find the IDFT of x of k using inverse radix 2 IDIT FFT algorithm. For this we have to use DIF FFT algorithm butterfly diagram, and at the end we have to multiply it by 1 by 8 and fiddle factor will be conjugate. X of k is given 0, 0, 0, 0, 8, 0, 0, 0. So butterfly diagram will be A, B, C is equal to A plus B, B is equal to A minus B multiplied with omega n of R star R. So here it is multiplied with omega n of star R. Should be multiplied by minus 1. Let us write the butterfly diagram for the given problem. So it should be multiplied by -1. This is omega 8 of star 0, omega 8 of star 1, omega 8 of star 2, omega 8 of star 3. Let us put the arrow marks for each butterfly. This is the second stage. Omega 8 of star 0, omega 8 of star 2. Omega 8 of star 0, omega 8 of star 2. Last stage will be -1 omega 8 of star 0. That should be multiplied by 1 by 8. So input will be in the normal order. X of 0 is 0, x of 1 is 0, x of 2 is 0, x of 3 is also 0, x of 4 will be 8, x of 5 will be 0, x of 6 will be 0, x of 7 will be 0. So first stage output will be 8, 0, 0, 0, minus 8, 0, 0, 0. So these are the inputs for second stage. Second stage output will be 8, 0, 8, 0, minus 8, 0, minus 8, 0. Third stage output will be 8, 8, 8, 8, minus 8, minus 8, minus 8, minus 8. That means the answer will be 1, 1, 1, 1, minus 1, minus 1, minus 1 and minus 1. So final answer will be in the bit reversed order, that is x of 0 is 1, x of 4 is 1, x of 2 is 1, x of 6 is also 1, x of 1 is minus 1, x of 5 is in minus 1, x of 3 is minus 1, x of 7 is also minus 1. So the answer normal order, x of 0 is 1, x of 1 is minus 1, x of 2 will be 1, x of 3 will be minus 1, x of 4 will be 1, x of 5 will be minus 1, x of 6 will be 1, x of 7 will be minus 1. So this is the answer for the given problem.